All right, so this one is called disproportionation. And what you'll notice about this is it looks a bit like a half reaction because there is only one reactant, yes? So you're going to look at this and you're going to say, okay, well, if that's the case, this is actually, some of it's going to turn into HBr, and some of it is going to turn into HBrO3. You will want to write this down unless you are an expert at balancing full reactions, because your quiz is when? Next week. Yep. Okie doke. So, normally, like it went back in our previous examples, we had, you know, it was like, oh, I know that my Cr2O7 turns into Cr3+, yes? Because those things both contain Cr. I know that HXE turns into my other HXE thing because they both contain Xe. And that's how I went about, you know, separating those two into half reactions. So for this one, here we go. We're going to, what's the first thing you do when you're balancing a full redox reaction? You split it into two half reactions. So we got Br2, it has to be the reactant for both of these, yes? So it is going to be turning into HBr, but it is also going to be turning into HBrO3. So those are going to be my two half reactions. Can you guess which one, right off the bat, which one is oxidation and which one is reduction? HBrO3, that's going to be your oxidation because you've stuck oxygen on it. Often, if you just stick hydrogen on something and nothing else, that's going to be a reduction. So if you've stuck extra hydrogens onto something, that'll be a reduction. But yes, this is going to be our oxidation here. So what is the first thing we balance when we balance half reactions? The major atoms. So is Br balanced in our first half reaction? No, so we need to put a 2 here. Second thing we balance is oxygen. Oh, look, there isn't any. How lovely. Isn't that nice? Yes, okay. So the last thing, no, not the last thing, the next thing we need to balance is hydrogen. Do we need to balance hydrogen? Yes, how many hydrogens do we need to add? We need to add 2 of them, 2H+. Okay, and I think that's it, except for, what have I forgotten? The charge. So to which side will I need to add electrons? To the left side, because the right side, my overall charge is 0. My left side, the overall charge is 2+, so we need to add 2 electrons over here in order to make it also equal to 0. So that's great. Our second half reaction, we have Br2 going to HBrO3. What do we balance first? The major elements. So we need a 2 here again. Second thing is oxygen. How many oxygens do we need? 6, not just 3, but we have 2 times 3 is 6 oxygens. So we need to have on the left side, we need to have 6 waters. That gives me how many hydrogens on the left? 12 hydrogen. And if you have trouble keeping track of things like I do, you might write it over on the side, you know, at the very edge kind of thing. And on my right-hand side, how many hydrogens? 2 hydrogens. And so onto the right-hand side, I need to add 10. My total charge on the left, what's the total charge on the left? 0. And the total charge on the right is plus 10. So to which side do I need to add electrons? The right side. Yes. How many? 10. Okay, and now I'm going to get rid of all my little scribbly doies because now they start getting in the way and confusing things. But I do like to write them down because otherwise sometimes I mess things up. We split it apart into 2 half reactions. We balance the 2 half reactions. What do we do next? Make the electrons in equal electrons out. So how do I do that? I've got 2 electrons going in here, and I've got 10 electrons going out there. What am I going to do to my first equation? I'm going to take the whole thing and multiply it by 5. And at this point, now I'm going to rewrite that. So now I have 5 times 2, and remember I like to touch everything to make sure that I'm not like goofing up on it. So 5 times 2 is 10 electrons. 5 times 2 is 10 hydrogens. 5 times 1 is 5 Br2s. And then on my right-hand side, I have 5 times 2 is 10 HBRs. And this is really making me regret that I drew this line here, because really what I want to do now is I want to add the fourth thing I'm going to do is I'm going to add my 2 half reactions back together. And because I didn't need to do anything to the second one, I don't need to rewrite it. You can actually add it all. I find I make mistakes when I do that, but it's up to you, okay? So let's cancel out anything that can be canceled out. What can we cancel? Because we're going to add this whole thing together. We have, yeah, we got 10 H pluses. What else? 10 electrons. And this should, if all goes well, we should at this point not have any electrons. If you have any electrons left at this point, guess what? You did something wrong and you need to go back and try again, okay? So now we're just going to add it up. We have 6 H2O plus Br2 plus 5 Br2 gives 2 HBrO3 plus 10 HBr. And I think I'm done. Yeah. Did I forget anything? Oh, 6 Br2. Oh, yeah. Yes, thank you. Was that a good review? Okay, yes. If they are all divisible, and yes, you should. So for this one, what should we do? Yep, so we want to reduce, if possible. And in this case, we can. And you don't even have to rewrite the whole thing. You could just go 3, 3, 1, 5. If you want to rewrite the whole thing, you can, but you don't have to. Yes? Saves you a little time there. Shall we do the more complicated one? Okay, so this is kind of, it's not the worst it gets, but it's kind of like the worst it gets. So if you look at this, we're like, oh, look, I have many, many things in my products. Woo! So my Mn, oh, the Mn is straightforward. What is Mn 3 plus turning into? It is turning into MnO4 minus. However, what is my FeSO4 turning into? It's turning into both Fe and SO2. No big deal. You're just going to put 2 of the products in your 1/2 reaction. Yes? Other than that, it is identical to what you have done before. You guys are going to learn this later. Your last unit. So, half reactions. We have, and I'm going to do them more towards the middle this time because that way it leaves me space on either side to put things. So we have Mn 3 plus going to MnO4 minus. And our second half reaction, we have FeSO4 going to Fe plus SO2. And those are our half reactions, and now we have to balance them. So, what do we got here? In our first one, we have, let's see, Mn is okay. What comes next? Oxygen. How many? 4 what's? Waters, H2O. What next? Hydrogen. How many? 8. And don't forget that it is H plus. And now I'm going to put my charges off to the side because I don't trust myself to get them correct. So over here it's a 3 plus, and over there it's an 8 plus and a -1. So that's going to be a 7 plus. Yeah? We're good? And that's why I write it out, because honestly, it's so easy for me to make a stupid mistake on that, right? Like, it's just way too easy. Okay. So to which side do I need to add electrons? To the right side? And does that make sense? We added on oxygen, so it's an oxidation, so it should be losing electrons. You can double check for yourself like that. You should be like, oh yeah, I've got oxygens here. My electrons should also be on the right-hand side. So this will be, is it 3 electrons I need? Yeah, 3 electrons. 4 electrons? 4 electrons, because I can do simple math. Sure, I can. 4 electrons. That sounds good. Okay. Yeah. And then we have to look at 2 different major atoms. We have iron. Is iron okay? Yes. Is sulfur okay? Yes. Nice. So now we're on to oxygen. To which side do I need to add oxygens? To the right. How many? 2. So I add 2 what's? 2 waters. Okay, and then to the left-hand side, I will need to add hydrogen. How many? 4. 4H plus. And oh, this one's so easy, I don't even need to write my charge because the right-hand side is 0, which means I need to add to the left-hand side 4 electrons. Oh my gosh! I don't even have to do my next step. What is normally my next step? Make the electrons in equal the electrons out, but what do I see? They're equal already. Oh my gosh, so I can just go around canceling things right now. Anything else I can cancel? I can cancel some of the waters, yes, so I've got 2 here, so that will leave me with 2. Anything else? Hydrogen, I have 4 here, so that will leave me with 4. And now I can add them up. Okay, so we now have 2 H2O plus Mn3 plus Fe SO4 goes to MnO4 minus plus 4H plus Fe plus, and I'm running out of room, so I'm going to write it down here, SO2. And if I did everything right, what should I not see in my redox reaction? Electrons. Am I good? Excellent. Oh, I need to make it basic. Okay. Thank you. See, you guys are better than I am. So what do I need to do to make it basic? Add OH. How many? To which side? Both. 4OH minus 4OH minus. And now we're going to add those in. Of course, these ones come together to make water. So we have MnO4 minus plus 4H2O plus Fe plus SO2. And over on our left, we have 2H2O plus Mn3 plus Fe SO4 plus 4OH minus. And is there anything left? We need to cancel out our H2Os. Yep, we've got 2 over here, and that can cancel with 2 of those to leave us 2. How do we feel about balancing full redox reactions? Pretty good. If you're not feeling good about it, I will be here for flex time on Monday. Yes? I will be here for flex time on Monday. So if you go home and you're doing these practice questions, also if you need to have some extra practice, you're like, I just want some extra practice before the quiz. Let's see where it is. Section 5.5. So page 207, okay? How much sorry, can't speak. How much of a review of titrations do you guys feel like you need? Thorough? Yes? Okay. So last week's package of stuff, and if you don't have it with you, don't worry, it's okay. We'll just, the notes will be up here. I'll post like the the notes with all the righty stuff on it, okay? So this is 5.2, is it A? C? What have I got here? Let me see. B, right, and it's in here somewhere. There we go. 5.2B, which I've somehow lost in my files somewhere, but that's okay. Did we do this activity? Did you do this activity? Yes? Did it make sense? Excellent. If you did not do it, what are you doing this weekend? You're doing this. And I will be very upset with you if you haven't done it by next week, because you have a long weekend this weekend. Yes? Very upset. Ms. Spence will like, oh, I don't know, I might do you know we had a teacher when I was in grade like 9, and she would take the meter stick and she would whack it on the desk. And it was like, oh, it was a shock to the system. Anyway, I also had a grade 8 teacher who was from Australia, and he taught in a private school where corporal punishment was still allowed. So every once in a while, he'd catch a kid and he'd whack him on the calves. Oh boy, it was a different time in the 80s. Anywho, yeah. Titration review, 5.2C. So it is simple stoichiometry titration. And stoichiometry is all about going from moles of substance A to moles of substance B. And in order to do that, you need to have a balanced chemical equation, yes? So this is like all of stoichiometry, but we are really only focusing in on this part right here. Because in a titration, what we're going to do is we're going to drip solution A into solution B until the two of them have reacted perfectly. Yes? With no excess of A and no excess of B. We will know our volume of A. We will know our molarity of A. And from that, we'll be able to calculate the moles of A. We use our mole ratio. Where does the mole ratio come from? Balanced equation. Okay, and we're going to finish off with moles of B, and from there we can do whatever we need to do with it. If you're asked for moles, you can stop there. If you're asked for grams, you can convert to grams. If you want moles per liter, you're going to take your moles and divide by liters, right? There's any number of things you can do with those moles. So let's take a look at this example here. It requires 15.6 milliliters. So I'm going to write down what I have at the start. So we have 15. So if you're following along without the worksheet and you want to write something down, you can write this down without that. So 15.6 milliliters of, and this is my H2SO4. 15.6 milliliters and 0.200 moles per liter. And you'll notice I'm writing it as moles per liter, not as molar, yes? No, this is in the old one. It is on page, I don't know what page it's on, hang on. 34? Page 34. And if you can't find it, don't worry, you can just copy down the this bit. So we have some information about H2SO4. What is the other thing we have information about? We also know something about our NaOH. We know that the NaOH, we had a 25.0 milliliter sample. We don't know anything else about the NaOH. We are asked to find concentration of NaOH, and that's what we don't know. What's the unit of concentration? moles per liter. So we need to find the moles, and then we're going to use these milliliters will be used down there. Yeah? So who is our known substance and who is our unknown substance? This is our unknown because we have a question mark. Yes, we don't know the concentration there. Do we know everything we need to know about the H2SO4? Yes, we do. So this is our known. So we always start with the known. Which is A, right in the diagram above. And what can we calculate about H2SO4 given the milliliters and the moles per liter? We can find the moles. Okay, so we're going to find moles of H2SO4. So we are going to say I have 15.6 milliliters. Oh, what should I do with those milliliters before I start calculating with them? Convert them to liters. Do I need to show that calculation? No, because you guys are big enough kids that you can just move your decimal place how many places? 3. So it becomes 0.0156 liters. Yeah? 3 places. 1, 2, 3. And we're going to multiply that by 0.200 moles per liter. Now this is where, do you need to write what you have moles of here? Yes, because you're dealing with two substances. If you don't write it, you will get confused. Yes? So this is moles of H2SO4. We could, if we wanted to, write equals and then just do the next step on the next line. Do you want to do it all in one line? Yes. Okay. So what is the next thing that we're going to do after we have found moles of H2SO4? We're going to use our mole ratio. Uh-oh. What do we not have? Balanced equation. Could you guys balance an equation between H2SO4 and NaOH? Yes? Why don't you guys try that? If you're having trouble, treat it like a double replacement reaction. Are we happy with my formulas? Do we like what I've written? Nobody's yelling at me yet. Oh. No, you don't like it? Yeah, we need 2 sodiums because SO4 is 2 minus, yes? So I need to have Na2SO4. And here's a little trick for balancing. Anyone having trouble balancing? If you do, your number of hydrogen and hydroxide have to be the same. So what you're going to do is you're going to say, I have 2 hydrogen, therefore I need 2 hydroxide. And guess what? How many waters does that make? No, 2. See, if you have a hydrogen and a hydroxide, you get an HOH, so you make 2 waters. So if you balance your hydrogen and your hydroxide, then your water is just exactly the same as them. Yes? Hydrogen and hydroxide just need to equal. So we now have a ratio. So we have 1 mole H2SO4 for every 2 moles of NaOH. And again, we could stop at this point if you wanted to, or should we keep going in one line? Keep going in one line? What I'm looking for is I'm looking for my moles per liter. So I'm looking for the concentration of NaOH. I have the moles on the top. Do I need to do anything to the top? No. So I'm actually just going to write a 1 on the top because I don't want to muck about with it. Yes? And what am I going to write on the bottom? Yeah, I'm going to use my volume from there, 0.0250 liters. If you wanted to stop at any point and do that as a secondary step, that's totally fine, okay? And we do that and we get 0.156 times 0.2 times 2 divided by 0.025 equals 2.496, which would round to 2.50 moles per liter, or 2.50 molar NaOH. Does that ring bells? Is that coming back to you? Yes? Okay, good. What are you doing for next week? Oh, I've probably punched a number on my calculator wrong, so probably this number is wrong. But you can calculate, right? You're better at it than I am. Don't forget you have a quiz next week. There is going to be another thing attached to, it's going to be 5.2, whatever it is, activity of metals. So check the teams for the homework. Quiz next week, check teams for homework.